Okay, so this question relies on your knowledge of sine and cos waves. The first one is just a basic sine wave, and you should know that sine and cos work in sort of units of 90. So point A is 90 on the x-axis, and point B is 180 on the x-axis. Now at point A, all sine and cos waves go up to 1, so sine goes up to 1, and point B is at 0. That's a nice easy one. Now this second one is much harder. If you imagine there's a different graph of f of x equals just cos x, what's happened with this equation here? Well, we have x times by b inside the function, and then we've times the function by a, and then we've added c on the end. So what do each of those bits do? Well, that affects the x coordinates. Basically that squishes it in if it's a positive number, sorry, if it's a number higher than 1, and it stretches it out if it's a decimal. So let's have a look at what we've got. We've got a normal sine curve would start here and end at this point here. Okay, but we've got not just one of them, we've got 3 of them between 0 and 360. So we've got 1, 2, 3. That means that B is squishing in 3. So B equals 3. Okay, the number on the outside shows us how far it's stretched in the y direction. Now this works as if it's a number greater than 1, it stretches it out. If it's a decimal, it compresses it in. So what's happened? Well, we'd normally expect it to be between 1 and -1, and so it's got a period range of 2, or on the y-axis it's got a range of 2. Here it's between 3 and -1, so it's doubled its height, so therefore a is going to be 2. And the c at the end here tells us how far it's shifted on the y-axis. If it's outside the function, it goes on the y-axis. Well, as said before, it would normally be at 1, and it's now moved up to 3. So it's moved up 2. So therefore C equals 2.